Today we will be talking about 3x3 matrices, determinants, and inverses. So remember in our last video, we talked about 2x2 matrices, determinants, and inverses. We're just taking this a step further and doing it with 3x3 matrices. So the determinant of a 3x3 matrix is a little bit more complicated than a 2x2 matrix, just because there's more to deal with. So you're going to expand any row or column of a given matrix by following the pattern. So here is a 3x3 matrix, and we want to expand by using row 1. So we're going to take the, let's see if I can make this a little bit smaller. All right, so we're going to take the absolute, not the absolute value. It looks like the absolute value. The determinant of A is determined by A. We're going to take the first element in the first row in the first column and take the determinant. Okay, so you're going to now get rid of, I'm going to use different colors here so y'all don't hopefully get too lost. So you're going to take what's not highlighted. So now you're going to take E, the determinant of E, F, H, and I, and then you're going to subtract it from the second element. So let's get rid of that because that'll confuse you. So then you're going to take the second element, which is B, in the first row, and you are going to now get rid of that middle column in that first row. So we're going to draw like a T. You're going to take the determinant of D, F, G, and I. That should be an I. All right, now you're going to add it to C times, let's get rid of that. So you're going to get rid of that last column and that last row to find the determinant. So D, E, G, and H. So that is how you find your determinant. It's a lot more complicated. I promise I won't give you too many of those. So to simplify this a little bit more, to write it out a little bit more, so you're going to take A, you're going to multiply it by E times I minus F times H, because now these are just 2x2 matrices, so we can use the same rule we did before. Now DI minus FG plus C times DH minus EG. So that's the letter form on how you do that. We'll do an example in a little bit, but we're not there yet. So now if we want to find the determinant of a 3x3 matrix, will the result of the determinant be different if it's expanded by row, column other than row 1? So we did row 1 above, that's why it's asking. No, the determinant will remain the same. I'm going to abbreviate determinant. Will be the same for any row or column. Any row or column. It doesn't matter. What will the determinant be if all entries of a row or column are 0? Your determinant will be 0. And if it has 2 identical rows or columns, that determinant will also be 0. All right, now we're going to talk about an inverse of a 3x3 matrix. So the inverse of a 3x3 matrix is the same as a 2x2, except we have to find the determinant of that 3x3, which is a little bit more complicated. So inverse of A, we need to find the adjoint of A and divide it by the determinant. Don't know why I just said discriminant. That's next chapter. All right, so now we're going to do an example where we find the determinant, which is lots of fun. I know y'all are super excited, right? All right, so we are going to use row 1 still. We're going to expand by row 1 instead of using a different row. I like to use row 1 just so I don't confuse myself too much. We're going to take the determinant of A, which, if you need to, refer to your notes back on the first page. That's fine. So you're going to take the first element in the first row and first column, which is 1 in this case. Then you're going to take the determinant of this 2 by 2 matrix that's not highlighted. 5, 6, 8, 9. And then you're going to subtract it by the second row element. The first row element and the second column element. So then we're going to get rid of that. First row, second column. And we're left with 4, 6, 7, 9 to find our determinant. And then we're going to add our third column, first row element. And then to find our determinant of this 2 by 2 matrix, we use the not highlighted. All right, so that's how you set that up. I expect to at least see this much, but I assume that you'll need to show some more work than that. So now we're gonna use these 2 by 2 matrices to find the determinant. So we're gonna take 1, and 5 times 9 is 45, minus 6 times 8 is 48. And then we're gonna do this one. 2 times the quantity, 4 times 9 is 36, and 6 times 7 is 42. Then we're gonna add 3 times 4 times 8 is 32, and 5 times 7 is 35. All right, so 1 times 45 minus 48, wow, is -3, which should just be -3. I don't know why I wrote the 1. And then we have minus 2 times 36 minus 42 is -6, plus 3 times -3, because 32 minus 35 is -3. When you add those all together, you will get 0. So what do we know about 0? When the determinant is 0, A is singular. So we can't find the inverse of that matrix because A is singular. So if I asked you to find the inverse of that matrix, you would tell me there is no inverse. All right, so we're not really going to expand this too much, but we're going to show that this matrix over here equals this matrix times 9, which is weird. Yes, bear with me. So I'm just going to say equals here so we don't have to write this matrix 1,000,005 times. So what I'm going to do is I'm going to take 3 times this matrix over here. So 2 on the left. 3, 0, 1. Actually, I lied. I'm taking row 2, the second row here, and multiplying everything by 3. Three from column 2. That's really great handwriting. Now I can take 3 more. 3 times 3. And I won't give you one of these. These are weird, so I don't really like them, but they're in the notes, so we gotta do it. 3 times 3. How would I get these guys, 3 and 6 in the second row, to be the same? So I gotta multiply by 3 again. So 2, 1, 0, 1, 1, 2, 2, 5, 1. When you take 3 from row 2, and then you'll get 9 times this matrix here. I will not give you one of these. They are super weird. Equals this matrix. And that looks like a 30 instead of a 3 and a 0. All right, so that's how you do that. But don't worry too much about that one. All right, so we are finding cofactors of matrix A. So we've never talked about finding cofactors. So first of all, you're going to need to know Mij, M sub I, M sub j. It's called a minor. It's a minor matrix. We've already used them. I just haven't officially called them that. when we found the determinant of a 3 by 3, we found minor matrices. So just bear with me and I'll explain that as we go because it's a little bit easier. But remember, I is your row, it's first your row, and J is your column. So just bear with me on that one. So we need to find, it helps if I have the pencil, A, 1, 2. So we want to find, I didn't even give you the formula. We're not there yet. Just jumping ahead. I'm jumping the gun over here. So if we want to find A, I, J, we need to find -1, I, -1, I to the I plus J, and then you're going to find your minor matrix and multiply them together. Actually, you're going to find the determinant of that minor matrix, which is typically a 2 by 2. I won't give anything more. So this is how you find cofactors. That's your cofactor formula in a sense. There's not a ton of formulas. I'm going to use that loosely because it's not really a formula. All right. So now it tells me to find A sub 1, 2. All right, so we know this is I. Let's use a different color. No, choose a different color. Let's use blue. So this is I and that's J. Okay, just as long as we know. So we have -1 to the 1 plus 2 power, and we want to find, so when we do this, you're going to get rid of row 1, you're going to get rid of row 1, and you're going to get rid of column 2, like we did over there, up there, with the stuff. So because of row 1 and column 2, that's what we want, so we are going to use -2, 1, 4, and 2 to find our determinant. So we are going to continue with this. So -1 to the 3rd power is -1. Then we're going to take -2 times 2. Let's put that in like some crazy brackets. -4 times 1. All right, so -2 times 2 is -4, -4. And then, so -4 minus 4 is -8. And so I get 8 for that. So my answer for A12 is 8. You're just going to get a number. That's a cofactor. And then we are going to do A22. Let's get rid of that highlighting. So I'm going to take -1 to the 2 plus 2 power, and then find the cofactor, the 2 by 2 determinant, sorry. So I'm going to get rid of row 2 and column 2. So my matrix is 1, 3, 4, and 2. Okay, so -1 to the 4th power is 1 because it's even, and then we want to take 1 times 2 minus 3 times 4. So 1 times 2 is 2, minus 12 gives me -10. Yes, you can have a negative cofactor. It's fine. All right, so let's get rid of these guys now, this highlighting up here. And let's do A32. So -1 to the 3 plus 2. As long as you got the formula, you're pretty good to go as long as you understand what what the formula says and how to understand it. And if you don't, come talk to me before your test. So we're going to get rid of row 3 and column 2. Apparently we just don't like column 2 today. So we're going to have 1, 3, -2, and 1. So we are going to take, well, this is going to be -1 because it's to the 5th power. And then we're going to have 1 times 1 minus 3 times -2. So -1 times 1 minus, actually that's going to be a plus 6. So I'm going to have a -7 is my cofactor for A to the 3, 2.